So now the next little piece of this is solving problems involving arc length, radius, and the central angle. I'm going to go back to a little drawing, or I'm going to make a little drawing right here. And what my arc length is if I draw a diagram that looks like this, where that's the radius, and of course that's the radius. The arc length represents the amount of the circle, or the perimeter, the piece of the circle that gets exposed at any given angle theta. Now it's very, very important that when we're talking about arc length, the angle is always in radians. So the arc length formula, it has to be in radians for the measure of the angle. And then of course R represents the radius and A is going to represent the arc length. Another equation that you guys could have is A equals R theta. And I believe that's actually the way that it's given on your formula sheet for Math 30, which I will actually post for this unit. A circle of radius 3 contains a central angle of 2.4 radians. Calculate the length of the arc subtended by the central angle to the nearest tenth of a centimeter. So I have A equals R theta. A equals, and my radius is 3. My angle is 2.4. So I get the arc length equals 3 multiplied by 2.4, and this would give me 7.2. So it's 7.2 centimeters. Calculate the arc length, the nearest tenth of a meter, of a sector of circle with diameter 9.2. Oh, diameter. So that means that first I need to go 9.2 divided by 2. And that would equal, I don't know, I went to a calculator for that one, 4.6 centimeters as my radius. And then the sector angle is 150 degrees. But again, very important for arc length, I need to convert this into radians. So I'm going to need to multiply this by pi over 180 to convert it into radians. And I get 150 multiplied by pi over 180. And this will give me 5 pi multiplied by 6. Now, since we're going to be doing this in decimal form, I could have found that in decimal form as well. But notwithstanding, we want to find the arc length. So we have A equals R theta equals 4.6 multiplied by 5 pi by 6. And then 4.6 multiplied by 5 pi by 6 is going to give me about 12. If we're going to the nearest tenth, then my answer would be 12.0 meters. A pendulum 30 centimeters long swings through an arc of 45 centimeters. Through what angle does the pendulum swing? And we want the answer in degrees and radians. So the pendulum is 30 centimeters long and the arc is 45 centimeters. Starting with A equals R theta, since we're looking for the angle this time, the angle equals A over R, or my angle is going to be equivalent to the arc, which is 45, not 4.5, and the radius, which would be 30 centimeters, because that's how long the pendulum arm is. So I get theta equals 1.5. Now we remember that is in radians. So that theta equals 1.5 is in radians. To convert that to degrees, I go 1.5 multiplied by 180 over pi. So 1.5 multiplied by 180 divided by pi, and this would give me 85.9, and this would be the degrees. What's the measure of the central angle in degrees subtended by an arc of 10 centimeters in a circle with radius 10 centimeters? So we have that the arc is 10 centimeters and that the radius is 10 centimeters. Or we get theta equals A over R, theta equals 10 over 10, or my theta would equal 1 rad. And if you go back to the very, very beginning and look at the definition of radians, this is actually the definition of radians, which is why it equals that 1 rad. From there, if we want the answer in degrees, well, it's going to be theta would equal 1 multiplied by 180 all over pi. So my theta would simply equal 180 all over pi. Now this next little bit, the area of a sector, you can read through this for your own personal benefit. If you were doing IB, this would be very, very important, but for us right now, you're not going to be asked any questions on it, and we're just going to kind of ignore that piece. So this is some homework if you guys want to give this a try. This first little bit isn't too bad though, so I'm not too overtly concerned. Hope you guys had a great day.